Hi, fifth grade. So we're going to go over some of the highlights and the practice set for lesson 80 of math. You need your book. You need to have read the entire lesson, all of the examples, and all of the solutions. You also need to have read my lesson explanation that I posted on Jupiter. This video is not going to negate the need for you to do any of that. I can already see myself making grumpy face at you guys. So I'm going to trust that you have read my instructions, read the entire lesson, and that this is just going over that information. Right, so lesson 80 is about prime and composite numbers. So we're on page 412 of your book. As you recall, a multiplication problem is factor times factor equals product. Factors are the numbers that we multiply together in order to get products. When we're asked what the factors of a number are, we're asked for those usually pairs, but for numbers that are squares, it'll just be one. There was one extra factor. Take, for example, 25. 25's factors are 1, 5, and 25. 1 times 25 equals 25. 5 times 5 equals 25, which is why you only list it once. So prime numbers are numbers that only have two factors, the number and itself. 2 only has two factors. 1 times 2 is 2. That's the only way that you can get 2 by multiplication. 3 is a prime number. 1 and 3 are the only factors. 4 is not a prime number because to get 4 through multiplication, you can either do 1 times 4 or 2 times 2. It has 3 factors. Numbers that have more than 2 factors are called composite numbers. Right? So prime numbers have only 2 factors. Composite numbers have more than 2 factors. The number 1 is neither prime nor composite. It only has one factor, which is the number 1. That's it. That's the only factor that it has. Right? So far, so good. If you look in your book on page 412, you have a really good chart of the first 10 numbers and whether they are prime or composite and showing their factors. Right? So an array is a visual representation of a multiplication number, well, a multiplication pattern. It's a rectangular arrangement of objects, numbers, or symbols in rows and columns. So you make a rectangle that shows pairs of factors. Okay? So if you look at your book on page 413, it shows you 3 different arrays for making the number 12 via multiplication. It has 3 times 4, 2 times 6, and 1 times 12. So that shows you what the different factor pairs look like. Okay. So looking at our practice set, our first one, A, says the first 4 prime numbers are 2, 3, 5, and 7. What are the next 4 prime numbers? Okay, so if you look here, 11, 13, 17, and 19 are the next 4 prime numbers. How did I figure that out? So I wrote myself a list of numbers, and then I want to go through and eliminate the ones that are composite. So 8 here, no, other hand. 8, nope. All even numbers greater than 2 are composite because they are divisible by 2. So 8, 10, 12, 13, 14, 16, 18, and 20 are not prime numbers. All right? Then I can also take out the multiples of 3. 3, 12, 15, 18, those all go too. All right? 10 is a multiple of 5. Oh, I already took out 10 because it's even. right? So my next number that I come to is 11. 11 is a prime number. You can only get 11 by multiplying 1 times 11. 13, you can only get 13 through multiplication by 1 times 13. And 17, you can only get it through 1 times 17 and 19. Okay, so my next 4 prime numbers are 11, 13, 17, and 19. Okay. B asks us to list all the factors of 21. Right? Is 21 prime or composite, and why? Okay, so the factors of 21 are 1, 3, 7, and 21. Therefore, it's composite. It has more than 2 factors. Problem C asks us which counting number is neither prime nor composite. The counting number that is neither prime nor composite is 1. 1 is neither prime nor composite. It only has that 1 factor. And then D asks us to draw 2 arrays of x's for the composite number 9. Use different factor pairs for each array. Okay, so you can see here that I've got 2 arrays. This one is for 3 times 3. I have 3 across and 3 down, okay? And then I have another one over here for 1 times 9. Those are my 2 pairs of factors that I can use to make 9. I can flip this way, and it still shows 1 times 9. But that means that's just the other way you can draw it. You can draw it the long way, or you can draw it the across way. Okay, so those are my practice. I hope this has been helpful to go over lesson 80, right? The highlights, prime numbers, only 2 factors, 1 and itself. Composite numbers, more than 2 factors. The number 1, neither prime nor composite. An array is a visual representation of factor pairs, making a rectangle with rows and columns. Okay, I hope this has been helpful. I'll see you guys here tomorrow. Bye, guys.